Okay, let's get started again, and then we'll start by answering the question first. So Suleiman is asking, I had a general question, is there any overlap between machine learning, AI, and the consciousness studies at the moment? It's a very good question, and also it's relevant to the discussion up to now on the cerebellum. But also it needs a little bit of a clarification. So if if your question is really just asking, is there any overlap between machine learning, AI, and conscious studies, then I would say answer is yes. There are some people who are trying to study or construct artificial consciousness. And also there are some people who are trying to upload the mind into machine in the future. I don't know whether it's going to succeed or not, but there exists such a people. And also in terms of AI and IIT can also be applied to the artificial structure and can have some kind of interesting prediction or explanation about it. But I want to ask you guys at this stage then, what your opinion is about artificial intelligence. So about so relaunch the poll. I put the 3AFC again, and here I want to ask you whether the circuits in cerebellum, is it similar to AI or machine learning, or cortex that is more similar to AI or machine learning? So in other words, maybe I should say current AI, is it more similar to cerebellum or cerebral cortex? AI similar to cerebellum. That's option A. And then cortex, cerebral cortex. That's an option B. And then unclear, I don't know, is option C or other. Okay, so yeah, without knowing what this AI or consciousness means, probably it's not that easy to answer. But so other is more dominant kind of answer so far. And there are some opinion about maybe it's closer to cerebellum or cerebral cortex. My guess, and also the actual architecture of the von Neumann style computing, which underlies pretty much everything that you have around you, like iPhone or computer or internet and things like that. They are, in fact, closer to this one, cerebellum, and very different from this. In the way that this is, in a sense, sort of the preparation of a bunch of specialized module, which doesn't talk to each other, right? And the cerebral cortex, as you will see in the future, they are actually connected to everywhere. It's not densely connected everywhere. If it's the case, then again, we will lose the information, which I'll talk about again later. But definitely, the cerebral cortex has a connection and interaction between each of them. And sometimes it's called a recurrent computation. And there are probably huge benefit in having this recurrent computation, even for the artificial intelligence or machine learning. But it's very difficult to also control and manage how to use it. So in the end, a current AI system basically rely on this cerebellum type architecture, which means that you might have seen some deep learning kind of algorithm maybe it looks like this kind of, figures. And that means that, information is passed from one state to another and so on to learn, let's say, text or your voice or images and so on. Okay. But the information flows in this direction only. And then during the learning, adjustment of, parameter, you use the information to go this way, but there is a trick to do that called back propagation. And it's not like each of the unit here is talking to each other. And that's what Cortex is doing, in fact. So roughly speaking, you can imagine that the current AI and the robot and machine uses cerebellar-like structure, and potentially, if it's the if IIT is the correct, then they are not really conscious, at least like like us. Does that answer your question? I think it was a good question because this was indeed one of the motivation why I wanted to talk about cerebellum. Thank you. Okay, so then let's move on to the next one. And in fact, the next one is also related to this question of the artificial intelligence and consciousness. In fact, what is the role of the prefrontal cortex for consciousness? And the prefrontal cortex has been shown to be important for various intelligent functions. And in fact, if you think about, intelligence and consciousness as one and the same thing, then naturally, prefrontal cortex has to be important for consciousness, right? And in fact, in some of the tutorials last week, we discussed a little bit about this, but up until 19th century, this is also discussed in Bernard Bars's classic review I suggested as a reading material this week. Many people thought that the consciousness, intelligence, and the rationality goes hand in hand. On the other hand, emotion, unconscious, animal instinct, all these things are also goes hand in hand. And the upper layer, conscious, intelligent, rational, controls the lower one, emotional, animal, instinctive, and also unconscious. That's a really strong, influential kind of thinking. And even some of us are still thinking like that. And then maybe if you talk to your mother or grandfather and so on, they still probably think about that way. And so coming back to this, this intelligence and consciousness used to be thought as one and the same thing, but there are lots of ongoing discovery that goes against this issue. So most of the consciousness researchers think that it's not the same thing. And the bilateral prefrontal cortex regions do not abolish consciousness, and important to distinguish functions, behaviors, and intelligence from consciousness. And minimally conscious patients, in fact, the locked-in syndrome patients are highly intelligent, but from the behavior ones, or from the function wise, he can't perform much, intelligent functions, but highly conscious, right? So this is a Phineas Gage, example. And if you have learned the consequence of this damage in Phineas Gage, what you learned in the psychology 101 is that Phineas Gage used to be quite reliable and also very honest person, but after the damage, he became very mean and socially inappropriate. But according to some of the description, he became even more intelligent by becoming rational and also not emotional, and then kind of calculating type of the personality. So it goes against this idea of intelligence and consciousness and are kind of serving or controlling the emotional aspects of the brain. And the prefrontal cortex is responsible for decision making, impulse control, judgment, emotion control, social interaction, and so on. All of these are highly desired kind of controlling kind of module for AI, and AI does do this, in fact, right? But it's unclear from this type of evidence whether it's relevant for the consciousness. And this is one of the many evidence, I would say, showing that prefrontal cortex may not be relevant. So this is the particular person who got the barbed wire from left to right during the Spanish War or something like that. And then this case study examined this long-term effects of the bilateral frontal lesions 60 years after injury. And this is a part of the excerpts of the paper. At the age of 20 years, he was forced to escape through a window and slid down a pipe that gave away. He fell and he was impaled through the head on the spoke of an iron gate. So that's this one. He remained there until the bar was cut. He was conscious and even helped in the rescue. So this is not super, surprising. In fact, if you read the novels or it's probably difficult to reproduce in war movies, but this type of the incidents, like wire stuck in the head and still continue to work is possible in human. Actually, the brain can be damaged, but still you can live and it will function depending on the type of the lesion. In fact, and the frontal part is especially okay to have the lesion, it seems. So the spike penetrated the left frontal region and passed through the both frontal lobes, injuring the left eyeball, and then emerged from the right side. His occupations consisted mainly of simple manual tasks that were always organized and checked by others. He required supervision and so on. So, again, social interaction and decision-making is impaired. He was incapable of planning and remembering. So this kind of, function is impaired, okay? But and he has this issue in terms of motivation and so on. But bilateral frontal damage does not seem to cause lower level consciousness, meaning that he actually does fluctuate in terms of level of consciousness. He sleeps and he becomes tired, and then he loses consciousness when he becomes he goes under sleep. And spares most sensory consciousness or content of consciousness, while profoundly alter his nature, human nature, and social interactions. So this means that in this particular type of the person, sensory conscious experience or qualia is there, but maybe the function-wise intelligence it may be impaired. So in summary, prefrontal cortex is important for various functions and behaviors for intelligence, but without bilateral prefrontal cortex, patients can live normal life. Why is the case? Can we distinguish functions and behaviors from phenomenology? That's a question. And potentially, some of the theory can explain why this is the case, but I will not go into much detail so far. So far, is there any question about this part? Okay, then we'll move on. What is the role of the posterior visual cortex for consciousness? So posterior visual cortical areas are responsible for phenomenal conscious visual experience. And the lesions in this area induce a blind sight most profoundly. Blind sight patients show striking dissociation of phenomenology and behaviors. So I don't know. So I know that some of the tutorial has already kind of mentioned about blind side, but I know that not so everybody knows what the blind side is. So I'll just explain. So this part of the brain, back of the brain, is a visual cortex, both left and the right side. Okay, and this is the one brain scan of the patient GY and another one HK. And both of them has a significant region in the visual cortex here that is very close to the input from eye. And then at the receiving end, in the case of GY, the left visual area is because of the convention, right and left is flipped. Left side of the visual field is impaired, and the HK left side of the visual cortex is impaired. Right side of the visual cortex is impaired. And then so yeah, this one is easier to flip and understand right and left. And then with this lesion, what happens is that when you flash a light at each location, one point by point, and then say, yes, I saw it, or no, I didn't see it, okay? It's called a perimetry test of the visual field. Then in the case of the GY, left side of the visual region, okay, this is very important, and I'm gonna probably ask it in the e-assessment, causes the impairment of vision on the right side. So he basically generally said that, no, I don't see the light on the right side. And the same goes in the flipped way, HK. Right side of the visual cortex leads to the left side of the visual deficit in phenomenology. So for it's fine, I think. And then, so this is a brain slice from top to the bottom, like sliced in this way, you know, from tip to the end. And then in this case of the patient, TN, who recently died, unfortunately, in South Africa, he had a lesion on both sides. You know, you see this is quite extensive, right? So in his case, he says that, oh, I don't see anything across everywhere. So that's their phenomenology, and that's what they report to the patient, and the doctor will trust basically what he was saying. However, in one of the experiment here, maybe it's not necessary to hear the sound, so I'll just play, okay? So this is a patient TN, and back behind him is an experimenter. And then there is an obstacle along the corridor, and they asked the TN to walk. And then TN was very uncomfortable because he couldn't see, and he wouldn't usually normally walk. But when asked, he did this. Notice that he actually avoided obstacle, and he became also slowing down. He slowed down his gait when he avoids the obstacle, and then he also circumvented the obstacle, and even he avoided stepping on the object on the floor. And this surprised quite a bit of the experimenter, because in his case, he wasn't able to even learn how to see this thing, because of the both sides of the visual cortex was quite impaired at the both sides, right? And another striking example, which actually preceded this type of the patient's report, is this quite close observation of the monkey Helen. And this monkey was controlled in a very controlled way, lesion on both sides of the visual cortex. But as you see, this Helen is moving quite normally after several months from the recovery, and can avoid these obstacles in almost like a normal way. And she can also find a small bait, and then can find it and grasp it, and then to eat it. So the point is that blindsided patients and also blindsided monkeys can behave almost like they are seeing. Okay, but if you ask patient here or other patient, they say that no, I don't see anything. And the question is whether they are actually lying or not. And that has been a huge debate over the last which has almost resolved over the last 20 or 30 years. But at the time of the discovery, it was a big kind of a controversy. So one of the critical experiments that lend the credence to their report is experiments like this. And this is a bit complicated task, so I may need to come back to this a couple of times. So here in this experiment, this patient was asked to fixate on this location, okay, on the cross, and then briefly, very briefly, presented two types of the locations on the display, and then they were asked to report what they saw in terms of a verbal report, and also make some kind of a button press or pointing response on the display. And then in this case of the HK, okay, who has a deficit on the one side of the brain, when this thing is presented in one side of the area, then throughout all the experiments, across all the contrasts of the stimulus, contrast here is defined by the strength of the black and white here. The contrast is defined by something like maximum black minus white divided by mean of the luminance and so on. So this means it's very, very strikingly visible kind of stripe. And the 9% is barely seen, visible. It's very faint kind of grading. And then this white square shows here that across all experimental sessions, this HK reported that, no, I didn't see anything. Okay, so that leads to this 0%. It's kind of quite a strange graph, but about the awareness, it is reported with the white square and then on the right axis. Okay, so regardless of the contrast of the stimulus, he says basically, no, I don't see anything. The behavior-wise here, percentage correct, black square shows that it's above chance. The chance performance is here 50% because it's either closer to the phobia or farther from the phobia. And he was asked to touch it or not. So after saying, okay, no, I don't see it, he's asked to touch, and then it's successful. And then as the contrast is highest, he's successful at the rate of like 70%. So that's a dissociation between awareness, phenomenology, report, and what he can do. And that's called a blind side. Okay, and this is the case of the absolute blind side. And this is a little bit more complicated kind called a relative blind side. So here, GY fluctuates in terms of the awareness. So in some session, he says, no, I don't see it. And then sometimes I saw it and so on. And then if very, very high contrast stimulus, GY can see it consciously and also can succeed in a behavioral response. But at the level here or here or here, maybe here and here, there is a strong dissociation between what he says and also what he can do. So that's also another types of the blind side. But the important thing here is that there is a dissociation between the phenomenology in their conscious experience and the report, presumably, versus objectively performable behaviors. So in summary, after lesions in the posterior visual cortex, patients reports at least loss of visual consciousness, and that's very common. And however, patients can move around like TN case, and also and so on. And one important issue about blind-sighted behavior or capacity versus normal people is that they don't do that usually spontaneously. So in the case of TN, experimenter and himself was quite surprised that he was able to walk around because he wouldn't do that normally, spontaneously, because he says he can't see it. So there's no point in trying to do it by himself, right? But when asked, he can do it. So that's the striking dissociation between behavior and report. The lesion of the monkeys seem to also be able to move around. And in the 2AFC task, two alternative force choice, that's important terminology, 2AFC. By the way, you also see this terminology of alternative false choice in the polls or quiz. So you should be familiar about this. And this is a very important kind of concept in psychology. In the two alternative false choice tasks, their behaviors dissociate from their phenomenal reports. And what it's like to be a blindsided patient is if you say that, even though I can see it, I just I deny it, then it's a bit unlikely to be probably true. But it's more like, your own ability that you cannot verbalize really well. We don't really know what it's like to be blindsided, but we can describe or characterize it through the different types of the tasks and also reports. So it's not super easy thing to answer, but you need to think about it, what it's like to be them. And one possibility is that it's like seeing everything faintly. And if that, so one of the controversy about the blindsided is to see whether it's possible to discriminate whether it's a total blindness or seeing faintly. And that's something that we will take a look in the next section. Okay. So I'll take a 5-minute break.